The job description of a design engineer involves the application of engineering principles to create, develop, and refine products, components, or systems. Design engineers play a pivotal role in turning ideas into tangible solutions through technical drawings, computer-aided models, prototypes, and ultimately, fully functional designs. Employed across a wide spectrum of industries, including automotive, aerospace, electronics, civil engineering, manufacturing, and consumer goods, they serve as the bridge between concept and reality, ensuring that each product is both functional and manufacturable. Design engineers are tasked with combining innovation with practicality. They work closely with multidisciplinary teams that may include mechanical engineers, electrical engineers, product managers, marketing teams, and manufacturers. By translating complex specifications into detailed technical drawings and digital blueprints, they ensure every aspect of a design aligns with performance, cost, safety, and aesthetic goals. Whether designing a new car chassis, an ergonomic medical device, or a next-generation smartphone, the design engineer is central to the engineering development process. A successful design engineer must master both creativity and precision. They must innovate while maintaining a strict focus on industry standards, tolerances, and feasibility. This role requires someone who can visualize how parts work together, adapt to constraints, and continually improve designs based on testing and feedback. The work is iterative, requiring multiple revisions, simulations, and collaborative reviews before the final product is released for manufacturing or client approval. Core responsibilities of a design engineer. Design engineers begin their projects by analyzing the client or company's requirements. These could include product functionality, physical constraints, safety considerations, regulatory compliance, cost targets, and aesthetic preferences. Once the criteria are clear, design engineers start with concept sketches, brainstorming sessions, and preliminary calculations. They explore alternative design approaches, weigh trade-offs, and often engage in design reviews with stakeholders to ensure alignment early in the process. A key part of the job involves using computer-aided design, CAD, software such as SolidWorks, AutoCAD, CATIA, or Creo to create detailed 2D drawings and 3D models. These digital representations include specifications like dimensions, tolerances, materials, and assembly details. Design engineers use this software not only to visualize products but also to simulate their performance under real-world conditions using computer-aided engineering, CAE, tools like ANSYS or Abacus. Design validation is another essential responsibility. Engineers must perform calculations and simulations to test the structural integrity, fluid dynamics, thermal behavior, or mechanical function of a design. They use finite element analysis, FEA, or computational fluid dynamics, CFD, tools to predict how designs will perform under stress, load, or environmental conditions. Where simulations aren't enough, they may build prototypes for real-world testing, collecting data that informs further iterations. Collaboration is integral to the design engineer's workflow. They work closely with manufacturing teams to ensure that designs are feasible to produce. This means understanding the capabilities and limitations of fabrication methods such as injection molding, CNC machining, 3D printing, or metal casting. Design engineers must optimize designs for ease of assembly, cost efficiency, and durability without compromising quality or functionality. Documentation is a vital yet often underappreciated part of the role. Design engineers must maintain detailed records of design iterations, calculations, materials, and revisions. These documents are critical for regulatory compliance, quality assurance, and cross-team communication. In regulated industries like medical devices or aerospace, thorough documentation is non-negotiable and subject to audits. As projects move forward, design engineers often support testing, troubleshooting, and refinement activities. If a prototype fails under testing, engineers must diagnose the issue and revise the design accordingly. This problem-solving cycle continues until the product meets all performance, safety, and usability standards. Midway through understanding their scope of work, it becomes evident that the job description of a design engineer encompasses far more than simply drawing parts. It requires critical thinking, scientific analysis, creative ideation, and the capacity to iterate until a concept is perfected and production ready. Required skills and qualifications. To thrive in this role, a design engineer must possess a strong foundation in mathematics, physics, and material science. A bachelor's degree in mechanical engineering, industrial design, civil engineering, or a related field is typically required. For specialized industries, a master's degree or additional certifications may be preferred. Proficiency in CAD and CAE tools is essential. Beyond technical know-how, a deep understanding of geometry, tolerancing, stress analysis, and thermodynamics is often necessary. Design engineers must be capable of using modeling software to create accurate, detailed designs and simulations that reflect real-world conditions. Problem solving is at the heart of this profession. Engineers must be able to identify design flaws, explore alternative solutions, and make data-driven decisions. This often involves troubleshooting unexpected outcomes and balancing competing priorities like strength versus weight or aesthetics versus cost. Creativity plays a large role as well. While engineers must follow functional and technical requirements, they are also expected to find innovative ways to improve performance, simplify processes, or enhance user experience. This creative thinking often leads to patents or proprietary design innovations that offer companies a competitive edge. Communication skills are critical. Design engineers frequently interact with clients, suppliers, technicians, and other engineers. They must be able to explain design concepts clearly, justify design decisions, and respond constructively to feedback. Written skills are equally important when preparing reports, design specifications, and user manuals. Teamwork is indispensable. Rarely do design engineers work in isolation. They are part of cross-functional teams and must collaborate effectively to ensure designs align with project timelines, budgets, and broader company goals. Adaptability and openness to feedback are traits that contribute to a harmonious and productive team environment. Work environment and career outlook. Design engineers typically work in office settings, although they may visit manufacturing floors, construction sites, or testing labs depending on the project. Most spend significant time on computers, using design and analysis software. Some projects may require travel to meet with clients, oversee installations, or troubleshoot on site. The work schedule is usually full-time, with occasional overtime during project deadlines or major design overhauls. The role demands a high degree of focus and attention to detail, as even a small design flaw can lead to costly manufacturing errors or product failures. Career growth in this field is promising. Entry-level design engineers often begin by supporting senior team members before progressing to lead engineer or project manager roles. With experience and expertise, they may become principal engineers, R&D managers, or product development heads. Others move into consultancy, academia, or entrepreneurship, particularly in product-based ventures. Certifications such as Professional Engineer, PE, status or Six Sigma training can enhance credibility and open doors to leadership roles. Continued learning is essential, as new software tools, materials, and manufacturing technologies constantly reshape the design landscape. Salaries vary based on experience, industry, and location but are generally competitive. Design engineers in high-tech or aerospace sectors often command higher compensation due to the complexity and regulatory nature of their work. Conclusion. The job description of a design engineer highlights a role that is foundational to innovation, efficiency, and excellence in product development. These professionals are the architects of tangible solutions, guiding ideas from inception to implementation with a blend of creativity, science, and technology. For those who enjoy solving complex problems, working with precision tools, and contributing to the creation of meaningful products or infrastructure, a career in design engineering offers both challenge and reward. As technology continues to evolve, design engineers will remain indispensable in shaping the future of how we build, move, and live.